Fundamental theorem of calculus part 1. This is the part that everyone uses all the time in the second half of Calc 1. Just integral of a to b is equal to the difference of some antiderivative. And so the way we're going to prove this is let P be a partition of AB. We're going to prove that we're going to head to L of f of P is going to be less than or equal to f of B minus f of A, which is going to be less than or equal to U of f of P. And then as we sum, this is going to be true for all partitions. And then that means that if it's true of all partitions, this is always an upper bound for this. So that means that if this is an upper bound for every partition, that means that the supremum of this has to be less than or equal to f of B minus f of A. And similarly, if this is a lower bound for all the partitions, that means that it has to be less than or equal to the infimum, which is this. And of course, these are both equal to the integral of f. Well, if a number is between the integral of f and the integral of f, that means that they're equal and we're going to be done. So that's going to be our strategy. We're going to show that regardless of the partition, f of b minus f of a is always stuck in between there. So we're going to let xi plus 1 belong to p. So these are adjacent. Here's a, here's b, here's xi, here's xi plus 1. There might be other things in the partition, but there are none in between there. Well, we can use, by the fundamental theorem, or by the mean value theorem, there exists a ti belonging to xi comma xi plus 1. So let's draw that into the picture. Ti such that f prime of ti is equal to f of xi plus 1 minus f of xi over xi plus 1 minus xi. That's all that is just means the mean value theorem. So I'm applying the mean value theorem to capital F, and I get this result. But I know that f prime is equal to little f. So this gives me little f of ti. So what do I know? So just rearranging here, I get little f of ti times xi plus 1 minus xi is going to be equal to, that was horrible, f of xi plus 1 minus f of xi. And now what we're going to do is we are going to note that if we look at the sum of xi plus 1 minus f of xi, this is always going to be equal to f of b minus f of a. Why is this? Let's just do a quick example. If we do a quick example, just kind of three of them, f of x1 minus f of x0 plus f of x2 minus f of x1 plus f of x3 minus f of x2. Well, what you notice is that, oh look, this x1 minus x1, x2 minus x2. You're always going to cancel everything except for the first term and the last term, and this is equal to f of a. It's actually equal to negative f of a, and this is just going to equal, the last one will always be equal to f of b. So these are always equal to that. Okay, great. Well, let's see what happens. And I'm going to stop here. I'm going to continue this on with the second screencast because I'm running out of time. So wait 1 second.